This is the wild coast of South Africa, where the Atlantic joins the Indian Ocean. On the 27th of June 2007, the container ship MV Safmarine Agulhas set sail into the high seas, but quickly lost power and crashed against the rocky beach. A salvage company that had famously raised the Russian submarine Kursk from the bottom of the Arctic Sea turned its hand to the second largest challenge in its short history. The Safmarine Agulhas was a 184-metre long and 25-metre wide container ship built in 1995. On the day of the disaster, the ship was carrying 22 crew members and 581 containers of goods from Europe, piled precariously high on the deck. 3-metre swells roiled the choppy seas near the breakwater that flanks each side of the ship channel entrance to the South African port of East London. A short distance out of port, the ship experienced its first engine failure. Winds relentlessly pushed the ship perilously towards the shore and beached and broke the bow. But then the engines began turning, and the great steel mass made its way out to sea again, only to experience a new power failure. Prevailing winds soon rammed her against the sand and rocks. With the container ship grounded, there was real risk it could break apart, emptying its 660 tons of heavy fuel oil into the sea and causing an environmental catastrophe, not to mention the loss of precious cargo. A Rotterdam salvage company, Smith Salvage, was called in to quickly debunker the ship and organize for its cargo to be removed. A 550-ton mobile Liebherr crane was brought in from Johannesburg and erected on the breakwater to begin removing the containers. The race was on, as cracks and fractures had begun to leak water into the ship, but not all of it was salvageable.
She's about 184 meters long and about 16,800 tons, and she had a cargo of containers.
On July the 7th, the ship's lights went out. In the next few weeks, the ocean rollers of the wildest South African coast broke its back, and the ship was split in two. The salvage was put out to tender, as the ship was now a wreck and had to be removed. A brand new company from the Netherlands landed the contract.
So, I mean, salvage is, there's a lot of engineering involved in salvage, but salvage is not an engineered job. So we engineer from A to K, and then from L to Z we'll find out on the spot. And you can have a lot of surprises in the second stage of your project.
To be honest, the dangerous part you don't realize because you're working. It's an adventure, so you don't want to see what's happening, so that's what you're doing.
The Agulhas wreck was the second largest in the history of Mammoth salvage, an offshoot of Mammoth heavy lift. The ship was a write-off, as it had broken in two. The insurance companies and owners had come to realize they had lost the ship, and now their only option was to sell it for scrap. The characteristic tower of the Mammoth Heavy Lift Company is where the engineers and salvors who raised the Kursk from the bottom of the Barents Sea planned the next successful project. Here is where the Salvage Master Fokko Ringasma, managing director of Mammoth Salvage, received confirmation that removing the Agulhas from the coastline where two oceans meet had been contracted to the newly founded Mammoth Salvage.
We were bidding against 3 other fellow salvors, and these salvors all had a solution of bringing this vessel back into the sea, because they come with a marine orientation. We came with a shore-based solution, where instead of bringing the vessel back to sea, we installed the chain pullers and we dragged her onto the beach and then dismantled her, which is much more environmental friendly, because all the disposal has been done on shore.
Han Sheet is a marine architect sent down to work out the technicalities and decide what equipment was needed to do the job. The location of the wreck was particularly challenging.
It was close to East London, and East London is a part, let's say, of the Wild Coast, there where there is a lot of current and where, how you call it, difficult weather circumstances meet each other. So it's not an easy path to work with, because you can have very rough seas and a lot of wind, and there is always a lot of current, and that makes it not an easy area.
Both Han and Fokker have decades of experience as salvage masters. It is a tough life that takes a toll on the men and their families, especially more recently with the liability mariners carry with regard to safety and the environment.
And the bigger exposure for a salvage master in today's world is the non-physical aspects of salvage. For instance, criminalization against seafarers, where we have to be very careful for. You as a responder go out to a casualty and rescue the vessel and save the cargo, but the cargo of the vessel or the casualty is leaking cargo, and you can be held responsible. And there are a number of cases where my colleagues were arrested and put into jail for trying to assist a casualty which was in danger.
Sometimes it's fun when you have nice projects, but sometimes it can be very hard and difficult. It's not always easy. Sometimes you go to countries which are not, let's say, favorite on your list. It's not always easy to work over there, so they're not always happy. Especially my kids, of course, because they don't like that I'm going abroad. But somebody has to make some money, otherwise we don't have the cheese on our bread.
The two colleagues started their careers together in the Persian Gulf during the Iran-Iraq War, where tankers were set ablaze by rival oil-producing nations, and the younger salvors were ready to take more risks.
One of the bigger salvage jobs I started with was the Barcelona, which was a tanker hit by the Iraqis, taking cargo on the Iranian side of the Gulf. And we were involved in a large wreck removal of the stern part of that section.
In this amazing film, Fokker and Han are seen during their work for a different salvage company in the Persian Gulf. They were exciting times, says Fokker.
Quite often the crew had abandoned the ship, and you get on board and you find nobody there to tell you what's going on. I mean, that's quite different in today's world now.
Together, Fokker and Han have experienced the best and worst of salvage, and have seen techniques change over time. The daredevil forays onto burning ships are a thing of the past, at least in their lives. But salvage is a cutthroat business, and the community is small. Often, competing salvors share the same hotels.
When the casualty has a high potential, the operations team is immediately ordered to go out on speculation and don't wait for the confirmation on the contract. But we quite often fly out boxes like these, which are all pre-packed with emergency response equipment, and our team's out on speculation, which quite often meet our fellow salvors at the same location, in the same hotel, and chasing the same owner's representative there.
This time, Mammoth Salvage came up with the solution that was most environmentally friendly. but presented complexities of its own. They arrived in South Africa and made their way to the site, where the situation they found was particularly problematic. The South African coast here is where the Indian and Atlantic Oceans meet, making it one of the most dangerous for shipping in the world. This shoreline is littered with wrecks, including the Smart, a bulk carrier with a load of coal that broke into 3 parts in 2013, when massive waves from each ocean met to multiply their height and terrifying power. Han Schiet and Fokker Ringersma found themselves managing one of the most dramatic shipwrecks of 2006. The Agulhas had broken in 2 on the rocks outside the South African port of East London.
Of course there are always problems, because that's the reason why they call us. It's an easy job, they don't need us. So there were plenty of problems. And yes, she was sitting on the breakwater, and that was number 1. And she was broken in 2, so there was hardly any buoyancy left. So the biggest problem was to pull her, let's say, on a small area close to the breakwater.
The team had been able to plan the salvage in their base in Schiedam, near Rotterdam, Netherlands. They drew on Mammoth's wide experience in moving massive objects. One of the world's largest heavy lift companies, Mammoth gained notoriety with the lifting of the Kursk nuclear submarine off the floor of the Barents Sea in the Arctic Circle in November 2001, and has grown since then, moving large objects the world over using an impressive array of tools and even engineering their own. Here in the company's training compound are just some of the massive cranes, strand jacks and self-propelled modular transports, or SPMTs. The Mammoth engineers came up with an engineering solution that was conceptually different from anything the competitors put forward. While other salvage plans had involved pulling the wreck out to sea, the Mammoth plan, says Fokker, was more environmentally friendly.
A previous salvage company tried to get her off the embankment in one piece, but this attempt was unsuccessful. The ship then broke in 2. Basically, the idea was to drag her on the beach and prepare the 2 sections, shorten them, and pull them onto the breakwater where they could be dismantled further.
Now, the equipment was not built on site, the equipment was built in Holland. The idea was scrapping the vessel with 2 cranes, and these cranes were coming from our South African company. And the other part of the project was pulling the vessels upwards on the beach, and that we used 8 chain pullers, and these chain pullers were designed and built in Holland.
The tools to do this mega move job were massive chain pullers. These winches were hydraulically powered with a pulling capacity of 300 tons each. Mammoth is specialized in machines that apply enormous pulling power, like the skid shoes, which work by pushing or pulling a steel skid using hydraulically powered pistons from one blocking position to another, 1 stroke at a time. Strand jacks work similarly, pulling 1 segment of cable at a time. The chain puller works in the same way, pulling the chain around a pivot and blocking it until another stroke of the piston is ready to tighten the chain by 1 more link.
Very simple, they're just 2 hydraulic cylinders with a clamp which is pulling a chain. 1 by 1 is pulling the chain. And yeah, you can create a huge pulling force. It is a very simple machine.
The massive chains had a mechanical resistance of 600 tons.
In our system we're using 3-inch U4 chain. U4 is the strength of the chain, and that's a little bit more than breaking strength of 600 tons, and we're pulling with 300 tons.
The idea was simply to pull the ship up the shore onto land. The difficulty the team would encounter was that the gradient of the rocky beach added resistance to the weight they had calculated. The equipment the Mammoet engineers planned to take to South Africa, apart from the chain pullers, were massive chains and oil-removing machines. 2 self-propelled cranes were provided by Mammoet's South African branch. They were needed to remove the containers that were still in the hold and bulky parts of the ship as it was cut up. All Mammoet equipment can be dismantled and shipped in standard containers to any part of the world. Pre-packed emergency equipment is ready at the airport.
To get your equipment on site is with these boxes, which we have all pre-packed with packing lists, all known with the customs already. They're stored at Schiphol Airport in a custom bond. So it's just a matter of sending this code to the dispatcher, and they can have it in 3-4 hours on a plane en route. The same goes for the teams. Sometimes they go by a liner, but if the connecting flight is too complicated or whatever, we charter a private jet and get ourselves team across.
According to basic calculations, the 3,500-ton bow section of the ship could be pulled up the slope using only 2,400 tons of pulling power, provided by 8 chain pullers providing 300 tons of force each. The plan was to cut the ship up during operations. The other massive difficulty was that the aft section, the heaviest, was also flooded and weighed 1.5 times as much as the fore section, and rested on an old wreck too, which meant that dislodging it and dragging it up onto the beach risked being especially difficult.
But the most nervous thing is, of course, will the aft section float or not? If she's not floating, then she's too far away from the beach. That will take extra time, extra days, then you're losing money. When she's floating, she's going very easily to the beach, then you're very lucky because then you're winning days.
The planners had to take another factor into account. The pulleys had to be fixed to the ground, and even the earth under them could give way under the weight of the ship. The team sought out very special help.
With Mammoet, the creation of pulling force is endless, but you need to have a very strong holdback position which can handle the forces. So we eventually found a company from Botswana. They were involved in diamond mining, and they drilled for us very deep holes with traction anchors and grouting it in the bedrock, some 14-15 meters below the surface.
These are the 8 ground anchors that serve as anchors for the pulling machines, and these are the pullers that are attached to the strong points by wires. These 2 are not being used yet, and these 6 are currently being used to position the front of the ship in order to pull it.
Before the work could begin, however, the ship and the terrain had to be prepared. Debris and superstructures were removed by cranes shipped in from Mammoet's offices in South Africa.
In the case of South Africa, it's very important for a foreign company to have the BEE status, which is the Black Economic Empowerment status, which we have through our office in Johannesburg. That is, in the case of submarine Agulhas, was it very, very helpful.
The cooperation of the local authorities was essential. Mammoet employed the local team to do much of the work, especially cutting up the hulk and removing the remaining cargo. The process of cutting the ship up to lighten the load could be carried out at the same time as the chain pullers were being installed.
We work also simultaneously, not only on the forward section but also on the aft section. So when we were, for example, removing the containers on the forward section, we already were preparing, let's say, things on the aft section. So the project was more or less running simultaneously.
One of the holds contained oil mixed with water that had to be removed to avoid all risk to the environment. They used a special oil removing machine to do the job. Environmental issues are especially delicate today when removing a wreck from a heavily populated area. And ports don't like bad publicity.
As a port, you also hold the selling point. In other words, if you advertise for a port, you don't want to end up with something that is of a vessel sitting on the other side, because they may perceive that as a low point to say there are more accidents in East London, and then may shift the cargo to another part of the world.
Well, I think when anything like this happens, obviously there is concern. There is concern about oil spillage, about spillage in per se, and it's a very conservation-orientated community. It has been contained, though there has been no spillage. In that sense, we're very lucky. We're also very lucky that it happened on the seaward side of the wall. If it had happened inside the wall, then we would have had major problems, obviously, to shipping movement.
Once the land-based structures were built, the team could begin attaching the chains. The sea and the waves have an unpredictable destructive effect on the structure of a ship, and inevitably the effect of moving backwards and forwards and twisting on the rocks weakens the ship's hull. Whenever a ship's hull is pulled either laterally or forwards, the stresses and strains on the material itself are one of the unknowns.
You make decisions where to make the strong points and all that kind of things, because that's got to do with the structure of the vessel. But you do that, of course, together, for example, with another team who is to install the chains, because I can say I want the bracket on top and he say we can't reach it. So you make always a decision together with other people what you can do, and then you make a calculation if it's possible.
Han Sheet was the naval architect responsible for attaching the chains to the Agulhas, and studied the ship carefully to identify the best place to locate them.
One chain runs through the bow propeller, one chain has been attached here to the double bottom, and one chain runs through the foot of the crane here, goes round here and out at the front.
6 years later, the Costa Concordia ran aground in Italy, on the rocks of the island of Giglio off the Tuscan coast. And here too, after 2 years in the sea, the resistance of the metal hull was literally a make or break factor in the success of the parbuckling.
There were two different ships. I mean, passenger ships, they are notorious for their light construction. I mean, they only have to be nice for the passengers. I mean, this was a container carrier and a relatively small one. So the strength and integrity of the hull was much higher than with the Costa Concordia. So we didn't have the challenge like they had on the Costa Concordia, where the structure of the hull was causing problems.
By the end of January 2007, the pulling had begun. Hour upon hour of revolutions. The chains slowly tightened under the power of the pulleys.
If you make a mistake and nobody else notices the mistake, and then you can get in trouble, because that can take, a cable can break and a winch can give way. Now, people can get hurt, and that's sometimes, that's a risk.
As the 3,500 tons of steel began rising out of the water, the friction against the rocks grew, placing more stress on the chains than the engineers had envisaged.
There are of course friction factors, and that's of course experience. We did this kind of jobs before, and sometimes you have to pull a vessel from the beach, and then you have always an indication of what the friction factor can be. And also over there we had an idea about the friction factor, and with the friction factor we calculate how much pull we need. And we were also trying to obtain some buoyancy in the vessel, so to make it a little bit lighter, and then we had the idea how far we can get the vessel on the beach.
With all the chain pullers at maximum power, any part of the wreck could collapse under the joint stresses of pulling and the waves.
But at the end of the show, the boulders and the rocks which were laying over there were a little bit bigger. Sometimes she was more a shovel than she was sliding over the rocks. So for that reason we need some more pulling power than we estimated. But that was no problem.
As the wreck was hauled onto the beach, one link in the chains at a time, the workers began cutting more and more steel away, so that once out of the water, and without the advantage of ballast, but with the friction from the rocks holding it back, the frame of the Agulhas was lighter and lighter. But at any time, one of the elements of the whole operation could fail. As the wreck of the Salvagemasters Agulhas was dragged up the slope of the rocky breakwater, it pushed stones up in front of it, increasing the friction on the hull and adding yet more weight that needed to be countered by the massive pulleys.
The aft section was some 150-200 meters away, and it was much more heavy. And all the information which we got from the P&I clubs and their consultants was that she was breached and she was flooded and she was sitting on another wreck and it was impossible to move her.
For example, also in this stage was calculating the buoyancy, because you need the center of gravity, the center of buoyancy. Is the buoyancy right? How much buoyancy do we need? Where do we put air? Where do we put water? And that's, I think, was a more difficult job than doing the strength calculations for just making strong points for pulling, because that's, let's be honest, straightforward.
The plan was to reduce the superstructure as much as possible, to reduce the weight the pulleys would have to counter. This was done while the bow segment was being removed, gaining days of work time, since in salvage, every extra day is extra money. As the bow section of the ship was being hauled onto the rocks, the rear was being cut to pieces.
And a lot of people are telling you, of course, the aft section can't float. It's impossible. And when she's floating, then I can assure you, then you're really happy.
In the meanwhile, divers were at work in the engine room, sealing any breaches that would reduce its buoyancy. This was an extremely dangerous job, as the segment was constantly being rocked by the massive Indian Ocean waves.
We spent 3 to 4 weeks of dive work from the inside of the engine room, because the outside you have a big, it's where the Atlantic Ocean and the Indian Ocean come together, and the big swells, they are meeting each other, so there's a massive swell and a very hostile and dangerous environment for divers to work from the outside. But we managed from the inside to patch the engine room and to pump her dry, which made her buoyant. And that was a pleasant surprise for us.
No, we created also buoyancy in the vessel. It was not a straightforward pulling power, but for example the aft section was first refloated and was then almost floating to the beach. Only at a certain stage there is no buoyancy anymore, and then it's only straightforward power of pulling.
The chains were attached to what was left of the aft section and started pulling.
Initially we had 8 of these machines standing over there. So the total capacity was 2,400, and during the process they were upgraded to 3,200 because we need a little bit more power to get the vessel a little bit more higher on the beach.
There was nothing anyone could do but increase the pulling power of the chain pullers. Now and again, a storm would break, and at times the waves, rather than hindering the work, actually allowed the pulleys to take advantage of the hull's movements.
The weather impact we more or less eliminated by having an onshore operation, where any other method of getting the vessel back into the sea would have a substantial weather delay because of what, like I told you before, the two oceans that come together and the huge swells. I think the weather delay for us was less than 10% when it was really rough weather and the waves were hitting the breakwater and washing some of the equipment off the deck and the breakwater itself.
Day after day and centimetre by centimetre, the bow section of the wreck was pulled out of the water until, at the beginning of February 2007, it lay on the rocks, ready for the breakers to come to reduce it to scrap. Now the most challenging part of the salvage could begin, the aft section. The massive fore section of the Agulhas wreck had successfully been pulled up on the breakwater of East London Port in South Africa, and now the salvers turned their attention to the even heavier aft section. The rectangular profile of the stern proved problematic. An added complication was that it rested on another wreck, and there was no way of knowing how much force would be required to pull it off. One stroke at a time, one link at a time, the chain pullers applied their massive power to dragging the wreck ashore. The rectangular profile of the wreck produced even greater resistance than the bow section, and as buoyancy was lost with the steel hulk being hauled onto dry land, so the machines had to handle even more weight. Here again, the section was constantly being reduced to its bare skeleton to lighten the load.
When we create buoyancy, she starts floating, so we can pull her easily to the beach. Then we scrap the top section off so that she became lighter and lighter, and every time when she's lighter, we can pull her, let's say, 10 or 20 meters higher on the beach. Then we can scrap another part, we pull her higher, then we scrap another part, we pull higher. And at a certain stage, the weight is reduced to such an extent that the pulling machines are strong enough to pull the whole vessel on the beach.
The east coast of South Africa, like all the Indian Ocean, is subject to the occasional cyclone, but the hardy Dutch salvers are used to far worse in the North Sea. Several storms slowed the process of removal of the wreck, but at the end of each, the sun returned and work resumed. At times, the swell of the waves actually aided the salvage rather than hindering it. Other factors were weighing on Fokker and Hans' peace of mind, however. The local authorities were anxious to have the wreck removed and putting pressure on the team. There was also the constant risk of pollution.
Where people are working, there will be pollution. To be honest, of course, we had a fire on board. We were cutting the vessel in smaller pieces, there is oil. But most of the time it was cleaned before it was removed. And otherwise, for example, if it was dirty, then it was cleaned ashore and then it was removed to the scrapyard or whatsoever. We had contaminated containers that were full with oil. Now they went to a cleaning site ashore, they were cleaned over there, and then they were either giving back to the owners or scrapped.
Salvage is also a business, and Fokker, as managing director of Mammoth Salvage, had worked out the cost of the operation on the basis of the time it would take. There was a double incentive to do the job fast. Once the bow section of the ship had been cut up, it made space for the aft section, which was also slowly but surely cut up into small parts for scrap. It is also the salvor's responsibility to leave the area clean and the environment safe. The secret of success in pulling the aft section out of the sea was giving it buoyancy despite the breaches and the debris that had accumulated in its hull.
The second part of the project, the back of the ship, is similar to that of the fore section, except that the aft section is much more damaged. Of course, the trick is to create buoyancy.
The Agulhas wreck had been successfully removed from the sea by 8 massive chain-pulling machines, but its rusting carcass still had to be cleaned up. Fokker Ringersma was satisfied.
All in all, we've achieved the goal we intended to achieve.
Both sections were scrapped in situ, were scrapped on site. So also the forward section, which was pulled on the beach, then we cut the top section off and went immediately to the scrapyard, because aft of the port, scrapyard was created, and they were cutting all the pieces and separating everything, and then it was going by truck or it was sold. And most of the time we went by truck to a coaster and was then sold to India, Pakistan or whatever.
At the maximum we had 75 people working on it. It was 25 Mammoth personnel, which did the offloading of the containers, the removal of the oil, the installation of the chain pullers and the physical pulling of the wreck onto the breakwater. But like I said, the Botswana subcontractors who did the drilling and the installation of the strong points. We had a diving company engaged in, because we were only a young company, years old, so we didn't have our own diving equipment and we didn't have our own divers yet. So we had a diving company involved in this.
The life of a salvage master involves travel and danger, not only from the elements or the physical working environment. Fokker himself has been arrested in the past, held responsible sometimes for events beyond his control.
Well, it's unpleasant, of course, because you got your home front, and I mean that's the main worry. We operate in areas away from home, and we make our own assessments whether it's safe or not to enter into the country. For instance, we're working now in Iraq, which will put a lot of question marks with your family and nearby relatives. The moment they hear Iraq, or the moment they hear that the husband or the father is being arrested in a country like Pakistan, it's more stressful for the home front than it actually is for ourselves, because we know the backup of our legal team and we know how to get out of this. But it is an unpleasant circumstance that has been added into the business of today, and which was not there 25 years ago when we started Salvage.
As managing director of Mammoth Salvage, in the increasingly competitive world of ship and offshore salvage, it is Fokker's responsibility to get his people in place quickly, either in time to provide immediate assistance or to assess the situation to provide a strong offer to the ship owners and insurers, known in the industry as P&I clubs.
Yeah, the moment you receive the call, usually it comes in through local port authorities, through local agents, or through the ship owner themselves. But mainly the ship owner themselves, they dig into also a legal protection. So the first call usually comes in through a friendly agent or subcontractor in that particular country.
In the salvage business, success often depends on a good level of access to decision makers, and that comes with experience.
So then the first thing is and that's not a Salvage Masters job, but that's the commercial side of the office, establish contact with the owners. Therefore you have brokers, or you sometimes have direct access to an operations manager who's dealing with the case. For oil companies and for offshore companies, you quite often have an emergency response center, and that's what I said. I mean, they put immediately a legal barrier around, so it's not always that easy to get into that. But our guys, they are very smart in getting access to these people, and then they offer our services.
Naval architect Han Sheet has responsibility for finding adequate technical solutions to every salvage, each different from the last. Mammoth Salvage draws on the decades of experience of its parent company, Mammoth Heavy Lift, and on the daring and unconventional leadership of its managers.
Every job is new. From every job you're learning something. Now you learn something about the friction. Now you learn something about the pulling machines. Now you learn something about a small container vessel. It's always something that you're learning about. Because, for example, you're walking all day on a vessel. Not all the vessels are the same. So every day you learn something about the vessel, about the machinery or whatever. And that's your experience, what you're winning with in the future.
The salvage of the Agulhas container ship was the first of the newly formed Mammoth Salvage Company, owned at the time by the Van Soimeren brothers, who had made their name raising the Kursk, when Mammoth was a heavy lift company only. Every wreck marks an era in the development of a salvage company, and the Agulhas was the first of many for this young organization. Once more, an unconventional approach was successful in salvaging this ship that bore a distinctive and ominous name.
That I don't know, but there is a huge current running always, and they call it the Agulhas current, the same name as the vessel. And that's a world famous current which is extremely strong.
The life of a ship salver is adventurous, at times dangerous, never tedious. From their earliest days in the Persian Gulf to breaking up a container ship where two huge oceans meet, Fokker Ringersma and Han Sheet never stopped seeking out their next technical and personal challenge. The Cabo de Hornos, one of the world's finest research vessels, today sails the southern seas. But just before its scheduled launch in February 2010, the ship risked being lost forever when an earthquake triggered a massive tsunami that threw the 2,000-ton vessel up onto the beach. A year later, the ship was saved by machines like this, the state-of-the-art SPMT transport trailers of a Dutch salvage company whose offices stay open 24 hours a day to respond to emergencies worldwide. The Cabo de Hornos is the pride of Chile's navy. It sails the Pacific, carrying out precious research into the environment of the Antarctic. It was built over 2 years in the Asmar shipyard in Talcahuano in Chile and cost a staggering $62 million. The ship was planned to have a top speed of 14.6 knots, and today is one of the 4 most advanced research vessels in the world. It almost never sailed. The earthquake that struck Chile at 3:30 in the morning on the 27th of February 2010 lasted more than a minute, and at 8.8 on the Richter scale was the 5th most powerful ever recorded. More than 500 people died, and the aftershocks continued for months, devastating the Chilean economy. Although the Cabo de Hornos stood ready for the official launch due hours later, there would be no ceremony that day. The earthquake caused a 2.5-meter high tsunami that devastated the towns of Valparaiso and Talcahuano, throwing boats onto the roads and beaches. The Cabo de Hornos was thrown onto the beach hundreds of meters beyond the dock it was standing on. The devastation was total.
And that beach, it was a black beach. There was old containers there. There was a part of a building washed up on that beach. There were the carcasses of dead sea lions. There was all kinds of debris around the ship. It was one big mess.
So this is one wheel bogie, and we have one bogie line. That's how we net it. So on this line, one bogie line, we can put 48 tons on. And then that means that we have to inflate the tires up to 15 bar air pressure.
And I must say that out of 10 cases, 80%, you go back home immediately, and on the 20%, you're the successful winners.
The salvage company, Mammoth Salvage, is based in Schiedam in the Netherlands and landed the contract to move the Cabo de Hornos back to the sea.
First, a few guys did an inspection, and they made the proposal for a contract, for the plan. Then the contract was awarded to us, and I came there, I think it was November 2010. We came there to execute the plan.
It took 10 months to agree on a salvage solution that would allow the ship to be delicately refloated for future use. Karel van Hoof made his way out to Chile and the port of Talcahuano in November 2010.
The situation was one big mess. The village where the yard was next to, there were cars everywhere on the roads, a lot of buildings were collapsed, there were ships scattered around on the roads, and the yard itself was also a big mess. There were the floating docks, they were everywhere, they were partly sunk, a lot of buildings were collapsed, there were still cars upside down everywhere. The ship was lifted a few days prior to launch, and it ended up on a beach where the yard used to drop their blasting grid.
Mammoth Salvage is an offshoot of the far bigger Mammoth Heavy Lift Company, based here in Schiedam, near Rotterdam, Netherlands. The company's claim to fame was the raising of the Russian nuclear submarine Kursk, which had sunk in the Arctic with a crew of 118 on board in the year 2000. Mammoth, together with another Dutch salvage giant, Smit Salvage, beat the Arctic climate to lift the Kursk submarine from the floor of the Barents Sea. The then owners of Mammoth, Frans and Jan van Zuimeren, persuaded the Russian government that their lifting techniques using strand jacks, a hydraulic compensation system for the waves, and specially designed plugs that opened when pulled could lift the submarine off the seafloor. It was a radically novel solution, suited to lifting the nuclear submarine still loaded with live torpedoes. Smith Salvage, a giant in the salvage business, supplied the massive barge and the cutting wire to remove the nose of the submarine where the torpedo compartment was located. Together, the Dutch salvors braved the winter storms and brought the Kursk back to Murmansk, together with its tragic cargo of submariners. After Kursk, Mammoth made a name for itself by combining heavy lift technologies with ship salvage. It is a cutthroat business, fraught with legal and technical challenges.
So then the first thing is to, and that's not a Salvage Masters job, but that's the commercial side of the office. Establish contact with the owners. Therefore you have brokers, or you sometimes have direct access to an operations manager who's dealing with the case.
Mammoth Managing Director Fokke Ringersma is responsible for persuading companies to let Mammoth do the job.
Yeah, the moment you receive the call, usually it comes in through local port authorities, through local agents, or through the ship owner themselves. But mainly the ship owner themselves, they dig into also a legal protection. So the first call usually comes in through a friendly agent or subcontractor in that particular country.
Mammoth Salvage is located in Schiedam, close to the main Mammoth Tower, and here the Salvage Masters and naval architects that put together the salvage plans store a range of maritime salvage equipment. Managing Director Fokke Ringersma leads a team of marine architects and salvage masters with decades of experience on the most extreme salvages. Not only the Kursk, but the Agulhas in South Africa and the ongoing Baltic Ace recovery in the North Sea. Mammoth's experience with heavy lift gave it the edge over its competitors when bidding for the job in Chile, as the ship was not damaged, just a long way from its natural habitat, the sea. It had been lifted by Mother Nature, and now would have to be lifted by man.
We respect each other, and we know that only one can secure the job. And well, you fight till the bitter end, and after that you shake hands with a successful winner of the contract. You wish him luck, and you offer sometimes your subcontracting services to him, and then you go back home.
The Cabo de Hornos is an advanced oceanographic and fisheries research vessel that is 74 meters long, with a molded breadth of 16.6 meters. It has an operating draft of 5.4 meters, and when fully equipped, weighs over 3,000 tons. At the time of launch, it weighed 2,000 tons and was empty of all equipment. Although the Tsunami literally lifted it out of the dock where it was ready for launch and dropped it onto a sandy beach nearby, the structure was still essentially intact. All about it lay devastation.
There were a lot of buildings were torn down in the village. They told me it was 8.8 on the Richter scale, so that's quite heavy. And the damage was destructive. Everything was torn down in the village. The roads were just washed away. There was a big stadium which was just cracked in half. There was a big gap in the middle. The damage was enormous.
The harbour area that Karel van Hoof found when he arrived was covered in the remains of collapsed buildings, and before any work could begin, these had to be cleared. In order to refloat the sophisticated research vessel Cabo de Hornos from the point on the sandy beach where the Tsunami had dropped it, several approaches had been discussed during the salvage planning phases. The simplest would have been to use skid shoes to drag the ship down to the water. Skid shoes are hydraulically powered brackets that move forward along a line of rails and hook into one steel sleeper at a time and then pull forward or push back. Here they are seen in action in another context, during the jumboization of a cruise liner in a shipyard in Palermo, Italy.
The original plan was, because it was a new built vessel, we had to treat her with great care. The original plan was to lift her up, put her on skid tracks and skid her back into the water. But as soon as we came there and reassessed the situation, we found that we better change the plan to put her on SPMTs, which are the modular transporters, and drive her back onto a barge and refloat her in a sheltered dry dock, so we're independent of the weather. And that was the plan we put forward to the yard. We proposed it to them.
The terrain was simply too uneven for the simplest solution, so the Mammoth salvers called in the heavy lift engineers who had an ace up their sleeve. Massive civil engineering work began to prepare the salvage of one of Chile's most costly marine investments. The SPMT is the world's most versatile heavy transport system.
We changed from the system because the skid shoe need a very straight track, and there was too much debris and containers and rocks in the way. And we found that for this particular case, the SPMTs were a better solution. It was also some kind of a gut feeling, more or less.
Well, from this control panel out, we can move one SPMT or up to 500 lines SPMTs. Yeah, we drive now 6 lines SPMTs, and from here out I can drive, steer the whole system and drive the whole system, lift up the whole system and down, up and down, and these are sort of lots of buttons where you can control the whole system with it. But on the end you're driving, that's only your left and right, forwards and backwards, and your lift system.
The Mammoth engineers are specialized in lifting heavy objects. Here, during preparations for the Mammoth Open Day near Schiedam in the Netherlands, they show off some of the equipment to their fans from all over the world. The main mover in the Mammoth world is the strand jack. This is a hydraulic pulley that moves a steel cable grabber up and down, pulling up dozens of cables by a few centimeters at a time, distributing the load among many cables and many strand jacks. Here in the Mammoth yards, workers are refurbishing and repairing used strand jacks ready for their next mission. Mammoth also owns some of the largest mobile cranes in the world, and this is one of Europe's largest. The new generation platform containerized twin ring crane is a new concept of crane that can be carried around the world in containers that are then used as ballast. Above all, Mammoth owns and operates hundreds of the most versatile transport in the world. The SPMT, the self-propelled modular transporter. Here in Schiedam, Michael Becks is one of Mammoth's most experienced SPMT operators. The SPMT was Mammoth's solution to saving the Cabo de Hornos research ship.
Here you can see which kind of direction you can do in a normal steer, diagonal steer, front, the steering point on the front, on the end, and you can do a circle drive. So that means exactly the middle of the trailer stays in the middle where it is, and then it turns 360 or how many you want to turn around. So you can drive from this point here, I can drive 180 degrees from here, I can turn it around, or I can drive 90 degrees full load.
The SPMT is actually an assembly of separate axles, each of which can operate either independently or in unison. The operator enthusiastically shows off the characteristics of an SPMT.
With this in here, there is an hydraulic cylinder, and with this hydraulic cylinder we bring the oil in, or we take the oil out from out of the control power pack, and we can lift up the trailer from 1.2 meters to 1.8 meters. Those 4 bogies are controlled out of these levers. I can do it by hand, always in emergency operation we can do everything by hand, but we do it from out of the control box, and then the computer send the signals to all valve blocks one by one. We have here 4 steering pistons, and there's a wheel in. It goes in here, connected to the button, and then the steering pistons will change from the direction and takes the wheel also with him. So it's like a slew ring, like a crane. It's the same, but then smaller, size like this.
The Mammoet SPMT can swivel on itself and switch a load around, just as it can move in any direction with the wheels all in parallel. These units can also be attached together to make one massive moving flatbed.
Those are the connecting poles, connecting pin to put a next trailer on it, on the front. And then here we connect all the hoses to give the next trailer also the oil and the power and the data what we need.
They are capable of rising by 60 centimeters to engage any loads that are suspended above ground, and lower them to be able to move them. A 6-axle line trailer has a 280-ton capacity. The PPU power pack is the control unit and can move many axle lines and control the hydraulics. All the movements are controlled via electro-hydraulic command that ends in the operator's remote control pack.
But you can do maximum 40 axle lines on one PPU, and that depends on the oil to feed up the cylinders. Power pack, this is like this. We can do 40 axle lines now, and it doesn't matter where the axle lines are. So when we need more than 40 axle lines, you need another PPU. But we can build it up till 500 axle lines where you want. But then you need a certain amount of PPUs for your hydraulic system. So there's 850 liters hydraulic oil in the PPU.
We started with the project, we started with the design of the track back to the dock, and then we start filling in all the gaps. We had to tear down a building, for example, to make some space, and as soon as we got everything outlined, we start filling in the gaps, deciding what equipment we needed, and then we bring in the equipment. So that took several weeks after the project started, more or less. Some of the SPMTs came from Singapore, other ones came from the States, from Europe. They were brought in from all over the world.
However, getting the 2,000-ton hulk to the port across the uneven terrain of the sandy beach was going to be a major problem, even with the versatile SPMTs. Since the sea was not accessible for skid shoes in the direction of the bow, and the dock was higher than the sand beach where the ship was resting, the salvors decided they would build a ramp to take the SPMTs carrying the ship to a barge floating in the dock.
It wasn't really on its side, it was like on maximum 10 10 degrees listing, so that's not really considered on the side. But it was actually standing right up there, and it was taken in the execution that we jacked her up, and then we jacked one side up more than the other side, so we got it completely straight up. And then we lifted the rest by the SPMTs, because they also have some lifting capacity, and then we drove the whole combination back onto the barge.
The team began working on clearing the area, laying down steel sheeting to smooth the work surface, and building a flat ramp over which the transports could move smoothly, while other contractors began preparing the ship for the lift.
First we draw out the path which was our plan with the SPMTs, because there was also a height difference between where the ship was resting and the dock height. So we measured it very accurately and made the path, because we can maximum be on a 4-degree slope. And that's why we had to tear down one of the buildings as well, because the building was in the path of the SPMTs. So we tore it down, and with huge civil works, we also made a dam around the ship and raised the level there for the sand, so we could. Otherwise, we couldn't reach the 4-degree slope we were planning to make.
Within a few weeks, the civil engineering pieces of work had been done, and the true heavy lift salvage work could begin. The Cabo de Hornos research vessel had not moved a single inch during the time it took for the salvage crews to prepare the terrain to get her back into the sea. The whole area had to be cleared of debris first, levelled and prepared for the massive move. Debris was removed by crane, digger and truck so as to eliminate any obstacle to the ship's smooth movement from its resting place back to the dock.
It wasn't completely finished yet, so for example, the piping in the interior and the engine wasn't completely finished. So prior to the refloat, we had to check all the piping, see if everything was shut off, closed off, all the valves were closed off. The superstructure, for example, wasn't built yet. It was only the outline of superstructure, but the whole flooring wasn't in, all the staircases weren't in, there was no electricity in the ship. So everything, we had to always carry our torch lights with us. And the ship itself had quite some damage, because before she ended up on the beach, she hit some buildings, and there was a lot of wear and tear on the sides, scratches, dents, etc.
The brackets were solidly welded to the side of the ship's hull, and the bond between them and the steel would have to carry the whole weight of the ship as it was being carried by the mobile platforms. The ship was like an injured patient being carried by the shoulders. Once the brackets were on and the ramp was ready, it was time to bring in the SPMTs.
The original plan was to jack it up, drive the SPMTs underneath and drive the combination back onto the barge. But then we found out that we run into problems with stability, because you have quite a high load which is quite narrow. So we decided to change the system and jack it up not as high as originally anticipated, weld the big triangles to the side and drive the SPMTs underneath. So our combination will be lower and wider, which is of course good for stability.
SPMTs are designed to be able to fit into a maritime container. Here at the Schiedam yards in the Netherlands, they are piled up, ready to be shipped to any salvage operation across the globe. Massive cranes are used to unload and load them to be taken down to the docks at a moment's notice. In fact, the Mammoth personnel are constantly preparing and repairing machinery so that they can be moved to an incident at any time.
So it's a parallel track for getting commercially your contract secured and operationally get your equipment and personnel as soon as possible on site. To get your equipment on site is with these boxes, which we have all pre-packed with packing lists, all known with the customs already. So it's just a matter of sending this code to the dispatcher and they can have it in 3-4 hours on a plane en route.
Actually, we just came there first with a few guys just to reassess the situation, and then we didn't have any material with us. As soon as we draw the plan and everything got its form, we brought all the SPMTs, the ballast pumps, we brought the jacks to jack her up, all the ramps. That was all brought back to Chile as soon as the plan was finished.
The SPMTs were sent to Chile in containers from all over the world. As they were unloaded one by one, they were put through their paces to make sure they worked. Once the axle lines required were put together with their flat top, they were ready to lift the massive load. It is the most flexible form of transport available to the heavy lift operations.
We used 84 axle lines, so 84 axes with 4 power packs, and I believe we had 16 jacks of 200 tons, something like that. So it was quite a lot of equipment. It was about 32 containers.
When they arrived, they were tested and put to work. The SPMTs were built up with bollards and wooden blocks to reach close to the height of each individual bracket. The fit had to be perfect to make the ride smooth and safe. Then the SPMTs were raised hydraulically until the blocks engaged with the brackets, and then slightly higher still, so that each bracket now bore the load of the ship and rested perfectly on the transports. The ship's keel rose off the sandy beach. The 2,000 tons of the ship rested on the 84 axle lines and their flat tops, which took the weight on their hydraulic suspensions and were ready to roll.
Yeah, we always say, I have to say I'm not really an expert on SPMTs because that's normally outside my work scope, but this was the first time I worked with them, and we usually say, that's what I learned, maximum about 25 tons per axle line, and this ended up around 17 tons per axle line.
While the SPMTs were being positioned, diggers and bulldozers moved the sand from under the ship so as to increase the free space under the keel, and positioned steel plates on the ramp to ensure perfect traction for the SPMT transporters as they moved towards the dock. In order to get the ship onto the ramp, the salvers needed to give enough space under the ship for it to be tilted upwards by 4 degrees. The SPMTs were linked together in 84 axle lines, 42 on either side, nearly 4,000 tons load capacity. Now it was time to begin moving the ship. The 4 diesel power packs provided enough power to drive up the ramp with ease. On the 26th of January 2011, the 84 axle lines moved in unison, under the watchful eyes of the operators.
We drove her up the slope, over the side of the dock, and then we drove her onto the floating barge, which then the whole combination was lowered.
The amazing maneuverability of the SPMTs is demonstrated in the Schiedam yards and was applied in the Chilean port too. Moving the ship up the ramp was relatively straightforward under the control of a single operator who maneuvered the 84 axle lines and 4 power units. By the time the SPMTs bearing the ship got to the edge of the dock, the real skills of the driver could be shown off.
The barge was, I believe, it was a 330-foot barge. It came from the east coast of the state, so we brought it all the way to the Panama gates, to the Panama locks, all the way down to Chile. And the ballast capacity was more than sufficient for a vessel like this. Those barges are typically used for transport of offshore structures, etc., and they're way heavier than this one was.
The ship and SPMT combination reached the edge of the dock the day after the move began. In the meantime, the dry dock was filled with seawater and the gates opened. A massive barge, the Mammoth 300, which was 87 meters long, 30.5 meters wide and 6 meters deep, previously used in the offshore industry and able to carry the full weight of the Cabo de Hornos research ship, had been tugged all the way from North America and down the whole coast of the South American continent. On the 27th of January 2011, it was towed into position inside the flooded dry dock of the Talcahuano construction yard and prepared to receive the 2,000 tons of the Cabo de Hornos research vessel. Once in position, the barge was securely moored and pumped dry to give it as much buoyancy as possible to take the weight of the ship.
There's one driver for the SPMTs. He controls the whole combination, and he can either carousel it, rotate it, or he can drive it. He decides where the combination is going.
The next day, the ship was driven over ramps onto the barge, an even more delicate operation for the driver. Any error could tip the ship on its side, and the barge was an unstable surface onto which to drive the units. The barge was pumped constantly to keep it afloat under the weight of the rescued vessel.
The ship was about 2,000 tons weight. It was a casco, she wasn't really fully built, so not all the equipment was there. And for example, the superstructure wasn't finished yet. So it was only the steel casco. And that was about 2,000 tons. 74 meters in length, about almost 16 meters wide.
The margin for error was a matter of centimeters. The ship had not only to be slipped down onto the barge, but also turned through 90 degrees to remain parallel with the dock and in the center of the barge.
But there's guys everywhere with radios telling what to do. You have to imagine, it goes very slowly. It's not like a 50 kilometer per hour operation. It goes really step by step. So the guy on one side tells him, hey, here you have a meter left, so he knows that and he can adjust his course for that.
The barge fitted perfectly into the dock and the ship on the barge, but the most critical element for floating the ship was the depth of the dock.
We found out that the most critical dimension of the dry dock was the water level, because it had to accommodate the dock blocks, the barge, the cribbing in between the ship and the barge, and the ship free-flowing itself. That was the critical dimension. The width and the length of the dry dock, they were more than sufficient for this.
It took the whole day to position the ship on the barge, swiveling the 2,000-ton vessel through 90 degrees using the unique turning capacity and versatility of the SPMTs. The SPMT driver swiveled the axles. Once perfectly positioned in the center of the barge, the hydraulic suspension of the SPMTs could be lowered, and once again the massive 2,000-ton research ship could rest on its keel. Slowly but surely, without damaging the ship, the supports were removed from the SPMTs, and then, eventually, the transporters themselves were manoeuvred one by one around the ship's hull and off the barge onto dry land.
We drove it onto the barge, positioned it in the right spot. There we lowered it back onto the deck of the barge. We took the SPMTs off. We had to cut off the triangles as well. So, because after the refloat we have to moor it alongside the quay. So in the overnight we cut off the triangles.
One by one, the 10 brackets, 5 for each side, were removed, and the dry dock could be slowly emptied.
We lowered the water level in the dock. The barge was resting on its dock blocks. Then we opened all the manholes and refilled the dock again. So now the vessel was free floating away from the barge. We opened the dock doors, she was stowed out, and then we closed the dock doors, emptied the dock again, lowered the water level, and then we emptied the barge so she came floating up, and there we had them separated.
The complex operations of filling, emptying and refilling the dry dock were complete at last. The submersible barge waited at the bottom of the dock as the Cabo de Hornos began to float. On the 29th of January 2011, the dry dock where the Cabo de Hornos research vessel of the Chilean Navy rested was flooded. The barge that had supported her during the first hours of her return to the sea remained at the bottom of the dock, as slowly but surely the proud steel ship began to float.
The atmosphere was great because there was an atmosphere of, they realized that we came there to help them. And we got all cooperation from the yard. Only the problems we run into was that it was very difficult to get our material because they were literally rebuilding the whole country there. So things like, especially the steel was very difficult to get, the wood was difficult because we needed quite big amounts of everything, and most of the steel was going into bridges, into other civil works. And that took a lot of effort to get that arranged.
The operation in Chile had lasted less than 3 months, from beginning to end.
We did the refloat, we did it more or less in a sheltered area because of the dry dock. So we were quite weather independent, but the weather was lovely. It was comparable to the Dutch or the British weather, more or less. We have had some rain showers, but nothing out of the extraordinary.
The Mammoth teams returned to their dockside base in Schiedam, near Rotterdam.
I think the first assessment team was about 4 or 5 people, and then later on we came around 20.
The moment the tender came out, then you indeed come up with a full throttle team, including your engineers, and then you're going to work out the details.
The Netherlands is home to some of the largest salvage companies in the world, and Mammoet is just one of them. Rotterdam is the center of the Netherlands shipping industry.
Yeah, funny enough, I mean, the Salvage Master has become more like the manager of the project, whereas when I started my career, it was really the hands-on man leading the salvage team.
Mammoet brings together the expertise of heavy lift and salvage, and in 3 major operations, the 2 worlds overlapped to make a rescue happen. The first of the series was salvaging the Kursk submarine, where Mammoet used massive strandjacks to raise the Soviet-era nuclear submarine from the floor of the Barents Sea, alongside giant of salvage, Smith Salvage, which provided the divers and cutting wire. Then in 2007 came the Agulhas, pulled ashore from the breakwater of the South African port of East London. Strandjacks, cranes and SPMTs are the staple of Mammoet as much as of Mammoet salvage.
I mean, with Mammoth we have in 52 countries in the world we have our own offices, and that's very helpful, of course.
Mammoth enjoys a fan club of over 5,000 people willing to pay to visit the Mammoth Open Day at the training centre near the Schiedam base. Here, the biggest mobile crane in Europe is set up near the Strandjack exhibit. It is able to extend the crane arm to 52 meters. And raise a load of 750 metric tons. Working with the world's most adventurous heavy lift company has helped Mammoth put forward innovative solutions for recovering wrecks and operating in the most complex situations. Ships run aground and sink all over the world in the most exotic and difficult situations. And anywhere where pulling power is needed, Mammoth can engineer the machines for each individual job. The ship was now completely outfitted with specialized laboratories and sophisticated marine and mapping equipment. In September 2015, a new earthquake struck Chile, this time 8.3 on the Richter scale and causing a new tsunami. The population and military set about clearing the beaches once again and returning displaced boats to the sea. This time, there was no need for the help of a heavy lift company. The rapid response people are on duty 24 hours a day, 7 days a week, ready to answer any calls for help anywhere in the world. The sun sets over the port of Schiedam and the headquarters of Mammoth and Mammoth Salvage. The sea lane remains busy until well after dark, and as night falls, the lights of the Mammoth Tower go on.
Cinq, 4, 3, 2, 1, top. Allumage P80, décollage.
On the 11th of February 2015, the European Space Agency's IXV Spaceplane splashed down in the Pacific Ocean. It was the culmination of many years of experiments and tests that changed the design of the spaceplane, allowing it to blaze through the Earth's atmosphere, bringing home millions of euros worth of scientific equipment. It was a technological triumph, but salvaging the European shuttle from the sea also required months of planning. Mission Control Center in Turin, the 11th of February 2015. The mission to send the IXV, the Intermediate Experimental Vehicle, into space was controlled from its own birthplace here in Italy. The 100-minute mission to launch the space shuttle from French Guiana into orbit and bring it back into the atmosphere at high velocity was the make or break moment for the engineers and technicians that had designed and managed the 210 million euro mission from the beginning.
What the IXV is designed to demonstrate is the re-entry into the atmosphere, so returning to Earth from space. Re-entry into the atmosphere is still one of the most delicate aspects of the space mission.
This is the first time that a private company perform a recovery operation like this, because usually it was performed in the past by Navy.
The IXV recovery in the Pacific Ocean was contracted to the Italian salvage company Fratelli Neri, a company with nearly a century of experience in ship salvage. Never before, however, had they salvaged a space plane. The Fratelli Neri have the largest salvage fleet in the Mediterranean Sea and regularly deploy their ships globally on salvage and transport missions. In 2012, they oversaw the debunkering of the Costa Concordia, and in 2013, they provided the equipment to cut up and remove the Gelso M cargo ship from the coast of Syracuse in Sicily. The company possesses the Mediterranean's only fleet of ocean-going fire ships, too.
Buenos Aires è un supply vessel anchor handling.
The Nos Aires is a supply and anchor handling vessel, so a ship designed to support offshore and oil platform operations, and to support all the operations for oil and gas exploration. So ships like these are able to follow a great number of operations.
In order to be able to carry out this special salvage, the company ordered a very special ship to be built. The Nos Aires was built in the shipyards of Shanghai and sailed all the way to Italy in time for the mission. The crew commander on this mission was Roberto Asaro.
La nave è stata acquistata circa un anno fa a febbraio.
The ship was bought from a Chinese shipyard about a year ago in February. It was then transferred to the Italian port of Livorno, where all the special equipment and superstructures required for this mission were mounted.
Carlo Collella is the project manager for Neri and worked closely with the European Space Agency's recovery team. He is responsible for turning the massive tug into a space capsule salvage unit.
The boat arrived in Italy in late April of 2014. We started then to a lot of modification on board, work to install a new crane, and I designed also the cradle where the spacecraft will be positioned after recovery, and the deep tray underneath as a basin, which we collect all the fluids that will come out from the spacecraft.
The Nos Aires is a DP2 standard ship, so it's a ship with a dynamic positioning system whose software automatically moves it in order to maintain a position set by the commander, despite any external influences.
Ciro Pipolo is the head of safety on the ship, which has been designed to face the most extreme fire situations, the main reason this ship was chosen for the mission.
Questo tipo di navi normalmente lavora con le piattaforme petrolifere.
This kind of ship is designed to work with the oil platforms, and it is designed both to provide support to these platforms to carry material, as well as to be a firefighting ship. And we have firefighting equipment that is able to extinguish fires on platforms.
The Nos Aires is a massive tug, 60 meters long and 16 meters wide. It is the largest tug in their fleet. On the 20th of October 2014, the massive tugboat left Genoa on this very special mission and began a transoceanic trek, first to Panama, and then the Pacific Ocean, while the IXV made its way separately to the launch pad in French Guiana. Here, France runs its own space center in Kourou, where for decades the legendary Ariane space rockets have been launched from. The IXV is a tiny capsule compared with the American Space Shuttle, but jam-packed with scientific equipment. It is designed as a lifting body, by which the shape of the capsule itself provides aerodynamic lift, despite being deprived of wings. The IXV carries special instruments to measure the effects of re-entry into the Earth's atmosphere by manned space vehicles. It is a test project that is designed to develop future modes of space transportation. Marie-Christine Contino is the recovery team leader for ESA.
So we are here in Panama because this mission has two phases. One is the launch and re-entry phases, and second is the recovery. So we are the recovery team. We are on board the Nos Aires ship, and this ship is starting to sail to the Splashdown area from tomorrow.
Although the launch and spaceflight parts of the mission had been simulated mathematically, the actual recovery of the spaceship was tested earlier at the Salto de Quira Interforce firing range in Sardinia. In June 2013, a mock-up of the Spaceplane was dropped from an altitude of 3,000 meters by a helicopter, falling to gain speed to mimic a space mission before parachute deployment. Parachute deployment was one of the major concerns. Would the flotation balloons pop out? Or might it sink to the bottom of the Mediterranean Sea? As the Spaceplane splashed down into the warm Sardinian Sea, the project managers were stunned that the flotation balloons did not pop out. The test mission was training for all the precautions that would have to be carried out in the real splashdown in the Pacific Ocean. The Spaceplane would still have highly flammable fuel on board and could spill some of it into the sea, creating a fire hazard for divers and crane operators alike. Parts of the Spaceplane could have become dislodged. It was a highly dangerous mission that would require precaution on air, land, and sea. The divers deployed to recover the mock-up first had to recover the expensive parachute and then proceed to discover why the vital flotation apparatus had not worked. They had to cut through the balloon covers and manually activate the balloons to ensure the Spaceplane floated while it was recovered. The test flight was a milestone for European space research.
L'operazione è un po' particolare in quanto l'unica problematica che
This operation is somewhat special in that the only problem we could encounter during the salvage is the presence of hydrazine. Hydrazine is the propellant fuel that is inside the capsule. However, to face this problem, we have specialized personnel aboard trained to clean out the fuel tanks of the capsule.
dei serbatoi della navicella.
A year later, on the 23rd of June 2014, the brand new Nos Aires, equipped with a custom-built crane, carried out recovery tests in the sea off Tuscany to verify that the specially engineered ship would actually be able to lift the spacecraft out of the sea and safely deposit the IXV onto its cradle on the mega tug's deck. Once the Spaceplane had been delivered to Kourou, the Nos Aires prepared the next phase of the mission and deployed to Panama port, where it began a series of test runs on its first and primary task, to recover the Spaceplane once it had splashed down into the Pacific Ocean. The crew of the ship and the European Space Agency engineers work together to prepare for every possible recovery scenario. many things can go wrong.
The main difficulty is the point that the propellant of the vehicle is not breathable, so it's a danger for the person. So we implemented all the operation with safety devices for the guys involved.
The ship's safety officer explains how the crew is equipped to handle the dangerous fuel in the IXV.
We have special suits for this type of operation that we will have to wear with breathing equipment, and the problem will be finishing the operation before the breathing apparatus runs out of oxygen. Otherwise, we will have to go back and get a resupply of oxygen.
Altrimenti bisogna rientrare e cambiare l'autorespiratore.
Oh, they will wear suits that are specially built for this kind of fluid, and we wear independent breathing apparatus to be independent from the external atmosphere. All the equipment will be explosion proof, because also the atmosphere could become explosive.
The firefighting equipment on board the Nos Arias is the most advanced of its kind, and the Fratelli Neri crew have been trained to face the most arduous firefighting missions, which every salvage operation needs to be ready for. Toxic and flammable chemicals are often part of the manifests of cargo ships, and salvers have to be ready for every possible catastrophic scenario. In the weeks preceding the IXV launch, the Greek-managed ferry running between Patras and Bari caught fire with a loss of 30 lives, and the local tug service, equipped with hydrants, was still unable to control the flames. Fire is the greatest single hazard in salvage missions, and the Nos Arias crew has trained to respond to it. The crane is designed to lift 8 tons and has an extension of 12 meters, more than any in the Neri fleet.
We have mounted a special crane which has a maximum arm extension of 11 meters, and that is rare on this type of ship, and it was mounted on the ship for this mission only.
We looked for a crane that was able to lift at least 8 tons at 10 meters from the ship, and the requirements asked for a crane capable to operate also in sea state 4. It means up to waves of an height of 2.5 meters.
La gru è un elemento essenziale del recupero della navicella, è una gru...
The crane is the essential element in recovering the capsule. It is an Italian-built crane, so clearly Italian, designed in Italy. It's a hydraulic crane with an arm extension of 12 meters and a lifting capacity of 8.5 tons. It can be operated manually by a driver on the crane or remotely by radio or wire guided.
The Nos Arias is designed to be able to haul huge weights using the specially designed crane, weights that otherwise risk capsizing the ship. As the project manager for Neri Salvage explains, this cannot happen with this advanced vessel.
We performed also stability calculation to verify that with the load on the side, the ship does not heel too much, but anyway, we have the chance to use sea water to ballast one side of the ship and balance the load.
The Nos Arias has been adapted to this mission in many ways that are visible both above decks and in the control room. The main element that is evident on the ship's deck is the firefighting equipment. This special saddle, with an underlying vat, is designed to host the IXV while it is being decontaminated of dangerous hydrazine fuel. The ship's bosun, Francesco De Vita, shows off the major safety features on deck.
Here I have the shower for emergency, because hydrazine is very dangerous, and have the shower for emergency, the technician or crew member. After, when I have this space shuttle on board, all is it's ready.
The two dinghies will be used to take the divers to the IXV space capsule floating in the sea. However, finding the capsule in the vast Pacific Ocean with its empty horizons will be tough.
Avremo a bordo anche dei sommozzatori.
We will have divers aboard who will swing into action as soon as the capsule has splashed down, and they will attach flotation balloons, as the capsule might suffer structural damage when it hits the sea, and as a result not float.
We plan to use two fast boats that with the divers on board will reach as soon as possible the vehicle that will be floating by its own balloon, and in case of need they can increase the buoyancy of the vehicle, connecting other balloons inflated on board.
This 2-meter diameter antenna is the main instrument that will help the crew find that needle in the Pacific haystack, maybe the toughest job on board, but only part of the mission that cannot fail.
We designed and installed all the equipment of the guys from ESA to take the telemetry data from the spacecraft. So we installed the antenna, all the telemetry kits.
There are two European Space Agency teams on board the Nos Arias mega tug.
So, well, at the moment, what you're looking in the background is the area where we control the naval station, which is installed on the IXV recovery ship. This station will be tracking the last part of the IXV mission before the splashdown into the Pacific Ocean.
One crew acts as the fourth tracking station for the space mission, recovering information from the IXV as it flies through space and monitoring its descent to Earth. Ivano Musso leads the tracking team.
We have prepared this equipment since 2009. We have designed all the systems, and now finally we are here to execute the mission.
The ESA recovery team was led by Marie-Christine Contino.
This mission has three objectives. The first objective is reentry demonstration validation, and second is technology demonstration, and third is expertise of all these experiments on board.
Mission Control in Turin, in Italy, at the headquarters of Thales Alenia, who built the IXV, will be in contact in real time, not only with the launch site in Guyana, but also the two tracking stations in Africa and the team in the Pacific Ocean. Ivano Musso is the ESA Control Room Director.
From here, we will receive the telemetry from the spacecraft. We will decode it, and we will send all the data in real time to the Mission Control Center in Italy. Then on the center part, we have the antenna control unit, the system that is used to control the antenna. The antenna is designed for the tracking of a spacecraft from a ship, so from a system that is moving. So it is provided with a stabilization system and a very accurate control system that is based on the reception of a real-time trajectory computation from the Mission Control Center from Italy. In the last part of our system, we have an additional equipment for the meteor sounding measurements, and also to provide to the Mission Control Center a real-time video of the recovery operations, because there are several difficult operations that our colleagues will have to do on the spacecraft to make it safe on board the boat.
There are two different kinds of data. One is the data on the experiment inside the spacecraft, And the other data is the data on the status of the subsystems inside the spacecraft. This is the data that is transmitted to the mission control system for the experts to evaluate how is the mission performing.
Without being able to track the spacecraft, the expensive instrumentation it carries is worthless. Night has fallen on Panama City, and the crew of the Nos Arias is ready to depart on the mission of a lifetime, the first space mission for this salvage company from Italy. Dawn rises over Panama City as the Nos Arias pulls out of port. On the 16th of January 2015, the Nos Arias left its berth in Panama for its position in the Pacific Ocean. Soon the skyline of this commercial hub will fade into the background as the mission to recover the multi-million-dollar European spaceplane gets underway. The goal of this tiny flying capsule is to measure the stresses that a spaceplane re-entering the atmosphere is likely to experience, so that one day in the future, space flight will be made possible. To recover the tiny spaceship in the middle of the Earth's largest ocean, the crew aboard the Nos Arias will be using telemetry and radio data delivered through this 2-meter diameter antenna.
The sailing to the splashdown will be about 2 weeks. And during this phase, we will do all the training to prepare for the recovery operation. So this is the first phases. The second phase is the launch chronology. So the day of the launch from Kourou. We will be in direct contact with the Mission Control Center and with Kourou Launch Center. And this is the phases where XV will be launched. We will follow the XV from different stations in the world, and the last phase, which is the re-entry phases and the splashdown phases, we will localize the XV vehicle from the antenna which is on board this ship.
On their way out to the position in the Pacific Ocean, the ESA and Fratelli Neri crews will work together to practice the delicate recovery operations. The ESA tracking team runs simulations directed from the Turin Control Center so that on the day their reactions to any unexpected events is immediate and seamless.
Telemetry kit is the core of the naval station. It is designed to receive the telemetry from the spacecraft, decode it and send the telemetry to the Mission Control Center in Torino. It is also provided of simulation equipment in order to execute a sort of internal test without the involvement of external centers.
During the mission, after the signal acquisition from the antenna, we will receive on the telemetry kit the telemetry data sent from the vehicle. And we will be responsible to record the received telemetries on these two recorders. We will track two frequencies, the vital one and the experiment one. So the two receivers are one for the vital and the other one for the experiment.
Meanwhile, the bosun Francesco De Vita and his team go through the motions of actually picking up the IXV out of the sea and dousing it with fresh water to avoid the fire hazard the deadly fuel represents.
When we have taken out from the water and put it on the boat, it will be safely secured. And then the passivation, what we call the passivation of the vehicle, will start. To perform the mission, the vehicle needs tanks from the reaction control system. But then, of course, as it is a high toxic propellant, we are not allowed to leave it in the vehicle for safety reasons.
The big day has arrived. The 11th of February 2015. The IXV has been prepared for this key mission to test the technologies developed for future space planes. In this unique mix of space and nautical adventures, operations in Kourou, in French Guiana, launch pad of the European Space Agency's IXV, are already underway. Once sealed in its protective fairing, the IXV is transferred to the mobile gantry for integration with Vega. The mobile gantry is rolled back for liftoff.
IXV is a re-entry demonstrator, so we will launch from Kourou, and after the separation we will have a small ballistic phase which goes over Africa until into the Pacific, where the actual re-entry will take place, and we will pick it up then from the ship out of the ocean.
Quando uno spazioplano tipo shuttle, tipo Soyuz, rientra.
When a space plane such as the shuttle or Soyuz re-enters the atmosphere, it undergoes a massive braking effect. It goes from 7,000 or 8,000 kilometers a second to a speed that is suitable for landing. It is an incredibly hard braking effect that produces extremely high temperatures on the outside of the shuttle or Soyuz.
The IXV is crammed with measuring instruments which will be key not only in navigating the spacecraft, but also transmitting information back to Earth in real time as it dives through the atmosphere and is subject to extreme temperatures. The IXV has been specially designed to be a compromise between a spaceplane and a traditional capsule. The European Space Agency has used both the Russian Soyuz space capsules and the US Space Shuttle as transport to the International Space Station that circles the Earth. Indeed, the tragic breakup of the shuttle Columbia on re-entry into the Earth's atmosphere shows how fragile spaceplanes can be. In 6 space missions in his career, astronaut Roberto Vittori has been subject to the massive forces that are measured in multiples of force of gravity, or Gs.
I have flown 3 times aboard the Soyuz and aboard the shuttle, and I can say they are tough moments both for the machine and for the people inside it. Re-entry with the Soyuz is approximately 4G. Re-entry with the shuttle is 2 or 2.5. It is the stage that, as we have seen with the Columbia shuttle accident, there is still a lot to be known, and that is why atmospheric demonstrators such as the IXV are important and will continue to be important.
The IXV is a lifting body without wings, but with control paddles that allow for some maneuvering in space via remote control from mission control in Turin.
XV per il futuro, per quelle che saranno le...
In the future, or at least as far as the development opportunities in Europe for the IXV are concerned, it will be important to give it wings, because without wings, we are forced to land attached to a parachute, which minimizes the advantage of being able to fly fast.
Minimizza il vantaggio del poter viaggiare velocemente.
Mission control is at the Thales Alenia headquarters in Turin, Italy. Here, engineers from all over Europe will track the different phases of the mission and monitor the data transmitted back to Earth in real time.
Roughly after 20 minutes, there will be a separation from the launcher. Then we will pick up the signal from a ground station in the west of Africa, in Libreville, in Gabon. So we can see the switch on of the vehicle, we can see the activation of the onboard systems. This will be followed by a station pass in the east of Africa from Malindi, where we see the continuation of these activities. And we will also, from this point onwards, have a good estimate where the actual splashdown will occur.
By 1 p.m., it's all systems go. Countdown is interrupted for a short while before resuming. There is a small window of time in which weather and light conditions are good enough for launch. The Nos Arias crew regularly send weather balloons up to gather data to send back to the launch pad in Kourou. The whole operation is dependent on the good weather at the launch and splashdown locations.
L'unica difficoltà che possiamo incontrare sono le condizioni meteo, perché essendo
The only difficulty that we might encounter are the weather conditions, because as it is an object that is a little delicate and fragile, it is important not to damage the capsule's structure. So as a result, a factor that will influence operations will be the weather. But in order to better handle this, the company has entered into agreements with weather stations which allow us to get weather updates even up to just 6 minutes before the capsule splashdown. So we will be analyzing the meteorological data and give the go-ahead for the launch.
dovremmo dare il benestare per il lancio.
After a short hitch in the countdown, the Italian-built Vega rocket with the IXV lodged safely in its fairing is launched successfully.
Allumage P80, décollage.
However, this is just the beginning of the mission. In these ESA simulations, the 3 most delicate phases of the launch are described. After just 2 minutes, the first stage Vega rocket falls back to Earth. Then after 3.5 minutes from launch, the second stage rocket detaches from the fairing, and finally the fairing itself separates 30 seconds later with the IXV flying autonomously, kept on course by its own rocket and paddle controls. An hour after launch, it begins falling to Earth. This is the moment of truth for the whole design and control team. Data is streaming to mission control, and then all of a sudden there is a blackout, normal for re-entry.
Well, many things can go wrong because it's an experimental vehicle. So everything is prepared and tested, of course. And from all what we know, things are done in a way that nothing much shall go wrong. But of course we don't know, and this is why we're experimenting with it.
A few nerve-wracking minutes, and the space plane is transmitting again. There is no indication of the state of the spacecraft at that time, but when splashdown occurs, the elation in mission control is visible. Now, will the European Space Agency IXV sink to the bottom of the Pacific Ocean, or float with the aid of its flotation balloons? Soon the world will know. The mission to recover the IXV from the Pacific Ocean has taken 3 years to prepare, but only 2 hours to finish. The spaceship begins its descent into the Earth's atmosphere as its instruments collect data on the performance of new materials in the heat-resistant tiles and monitor the thermodynamics of the tiny craft. Back in Turin, where Mission Control is monitoring the progress of the IXV, all the data collected is processed and passed on to the Nos Arias, telling the crew and ESA team where to search for it in the wide open ocean.
From the Mission Control Center, they will send us all the data from the vehicle before it will splash down. So they will provide us information very, very important for right operation on the spot, because they know if the parachute will open or if flotation balloon has opened. So we can prepare as a consequence of what they will say to us.
There is another system to indicate where we should go and look for it. This other system is let's say, is managed by another team, which is the recovery team, that should take care of the recovery operations and getting the vehicle back on board.
As it plummets through the atmosphere, it is slowed down from 17,000 kilometers per hour to just Mach 2, or approximately 2,000 kilometers an hour. The atmosphere further slows it down to speeds that allow its parachutes to deploy, and then the IXV splashes down into the ocean just north of the equator near the Galapagos Islands. Celebrations erupt all over the world, from Kourou to Turin, as the speedboat crews prepare for action. On the Nos Arias, the ESA team identifies it first by radar, then by telemetry, and as soon as it splashes down, 2 speedboats are sent with divers to scout it out. What will they find? Will it be afloat? Will the sea round it be covered in deadly hydrazine? The team in Turin waits with bated breath.
Once we know that the ship is safe for the people to go there, then we start the recovery operation, will be to take the vehicle out of the water and to put it on the ship. Then we will store the vehicle safely on its cradle, which is already prepared here. And once everything is done, then we will start the decontamination of the vehicle.
In seguito alla
Once the capsule hit the water, the Nos Aries sailed towards the splashdown area, where the divers and specialized personnel had already carried out the first phase, the initial approach, and they had made the vehicle safe.
Gli operatori specializzati che hanno eseguito la fase iniziale, il primo approccio e la messa in sicurezza del veicolo.
Once they arrive at the site, the divers are able to ascertain that the spaceship is indeed floating, that the balloons have deployed, and that the sea is safe. They wait for the Nos Arias to approach. Now, they attach slings to the spaceship, and the special crane mounted aboard the Italian tug ship raises it to deck. The decontamination squad is ready and waiting.
Domenico, controllo pressione.
Abbiamo approcciato appunto il veicolo che galleggiava.
We approached the vehicle that was floating on the starboard side of the ship. Slings were placed under it on the starboard side, and they were very tense moments.
In una fase che può sembrare abbastanza concitata.
They may have lasted just a few seconds, but it seemed a very long time as the capsule swung quite a lot due to the ocean waves that were quite high.
Comunque una presenza dell'onda oceanica che non era.
But eventually the capsule was placed on the saddle located on the deck and fastened down adequately.
Sulla sella che era posizionata in coperta ed è stato assicurato tutto al ponte in maniera adeguata.
The safety crew douses the spaceship with water to dilute the propellant and secures it to the specially designed cradle. The hydrazine is purged from the vehicle, and it is prepared to return to base. Back in Turin, astronaut Roberto Vittori comments.
We saw today with the launch of IXV that it took off from South America and in an hour and 40 minutes reached close to the coast of California, so a very short space of time. But there was need for a ship to go and recover it. So it is clear that the two aspects contradict each other. The speed of travel on the one hand and the complexity of recovery on the other. It's only with wings that we can ensure that the craft can land and also that it can be reused.
Once rendered safe to access, the team from Thales Alenia and the ESA can approach the spaceplane and extract the invaluable data collection cards that gathered the information that the IXV was sent into space to collect. As the Nos Arias tug plows the ocean waves to return to Europe, the success of the €210 million mission can be measured by the results obtained. There is cause for celebration.
Nei giorni successivi l'équipe del personale francese.
In the following days, the French team carried out the pacifization of the vehicle, so they extracted the propellant fuel that was in the fuel tanks and the circuits of the capsule and put it in a special container where it was pacified using hydrogen peroxide to make it harmless for the ship and for the personnel.
In maniera da renderlo inerme per la sicurezza sia dell'imbarcazione che del personale.
On the 21st of March 2015, the Nos Arias pulled into Livorno to dock again alongside the other Fratelli Neri tugs and fireships, ready for the next mission. Aboard was the IXV in its container, which was ferried back to Turin. The IXV is just one more step in the development of a viable spaceplane concept for suborbital travel. There are still many phases left. The Nos Arias has joined the Neri fleet in Livorno and was immediately sent off to another mission to salvage a Turkish ship that sank off the coast of Ravenna. But this is another story.
Dawn rises on a hot June day in 1996 over Matagorda Bay, Texas. Archaeologists are excavating the 58-foot French Barque Longue ship that sank in 1686. A groundbreaking Coffer dam was built for a scientific salvage operation that would allow shipwreck conservationists to rebuild the doomed ship, finally unlocking its long-held secrets. Austin, the capital city and cultural hub of Texas, finally marked a moment that marine archaeologists, divers, Texas state government agencies, and private donors had been anticipating for 20 years, since the discovery of one of the most important shipwrecks in American history. The hull of the La Belle shipwreck, painstakingly taken apart and put back together timber by timber, was gingerly placed in its final resting place at the Bob Bullock Texas State History Museum. A world-class exhibit will now house the remains of that ship and many of the 1.6 million artifacts found on board. These finds lay submerged on the floor of Matagorda Bay off the coast of Texas for over 3 centuries. Only today are historians unearthing the whole truth about La Belle, the small ship on a big secret mission to wrest territory from the Spanish. Its sinking changed the course of American history.
There's no better way to learn about historic shipbuilding than to reverse engineer a ship that was built in the historic period. Seldom do you find the entire ship. You find what's left. In nature, preserved for us the bottom third of the hull with lots of cargo in there, and that cargo represents a kit for building a colony in the 17th century New World.
For nearly 2 decades, Dr. Jim Bruzeth and Dr. Peter Fix have been working on a project to salvage and restore La Belle and its artifacts. Fix is the head conservator in charge of the La Belle archaeological remains, while Bruzeth, a marine archaeologist working for the Texas Historical Commission, took over the archaeological excavation soon after it began.
Inside La Belle, when we excavated the wreck, we weren't certain what we would find, but as time went on, we ended up finding over 1.6 million artifacts in what was actually the preserved bottom third of the hull.
La Belle here behind me is just the largest of the artifacts, but all of these artifacts have been stabilized over the last 17 to 18 years.
I'm guessing right now that the total cost of La Belle from discovery all the way to where we are today, building this beautiful exhibit at the Bullock Texas State History Museum, is going to cost about $18 million.
Bruzeth vividly recalls how his team used ancient maps, journals, and a magnetometer during the initial search for the French explorer's ship.
We decided we were going to go out and find La Belle. It took some time and took a few years and different tries, but eventually in 1995 we went out with our boat, a special boat that had an aluminum hull, and it towed a magnetometer behind it, which is like a super sensitive metal detector.
Shipwrecks such as La Belle contain many iron objects, from their bells to the bolts used to fasten the timbers together. That iron gave away its location. Chuck Mead was one of the divers looking for La Belle. Returning to the site of the La Belle discovery, he recalls how the equipment tipped them off.
All we really knew is that there was a source of magnetic magnetism. You know, there was iron somewhere on the seafloor. And that's often a shipwreck, but it's often modern debris, something that we're just not interested in. So we start sending divers down. And of course, we pretty quickly realized what we had.
Chuck's initial find in the murky waters of Matagorda Bay would make history. Here, 20 years later, he went back to see it.
And then all of a sudden, I put my hand down on what feels like a metal handle. It's a solid, it's made of metal, it's attached to something big and heavy, and the very first thing I thought of was like, oh, could this be a cannon?
And a few days later, we brought up this beautiful bronze cannon with French wording on it. And we were very excited because we knew we must have an old shipwreck with a cannon, and it's got French writing, and there aren't that many French shipwrecks that have wrecked off the Texas coast.
The stamp on the cannon had the mark of the Comte de Vermandois and a clearly defined serial number, which matched a ledger of weapons belonging to the French Navy at La Rochelle, France.
That was the confirmation we needed that we had found La Belle, what has now become one of the great shipwreck discoveries in North America.
Historians determined the ship was the La Belle, the hardy but small vessel that French explorer Robert Sieur de la Salle used to cross the Atlantic in search of the Mississippi River in an expedition that would last from 1684 to 1686. The team of divers found the cannon and several other small artifacts, but it was soon clear a larger, more complex operation would be necessary. Marine archaeologist Barto Arnold, credited with the La Belle discovery, decided to use a coffer dam, a circular dam that allowed for a dry archaeological excavation.
The methods that are used to excavate an archaeological site, to accurately map in artifacts and record the timbers and other components and features of a shipwreck site, a lot of those methods were developed for high visibility shipwreck sites. And those methods can be very, very accurate and often are. But for black water sites, and this is the environment that Belle is from, where you have zero visibility or less than 6 inches of visibility, those mapping techniques aren't feasible.
We needed to do something different. A traditional underwater diving excavation, which would have been possible, would have been tough. Archaeologists do that, but it would have been tough, and it would have been more difficult to get small, fragile artifacts recovered. So we really thought in a way that hadn't been thought before anywhere in this hemisphere, and that was to build what we call a coffer dam, a giant steel structure around it, and then we pump the water out.
An engineer who specialized in oil rigs was given the job of designing the cofferdam. David Gann knew the area where the ship had sunk like the back of his hand.
But he was familiar with how to, and had worked with building walls with sheet piling. But he had never built anything where, normally the sheet piling is used where you anchor it into land and you come out into the water. Here we were completely out in the middle of Matagorda Bay, and we had to have the sheet piling form basically an oval in the water.
In 1996, the cofferdam was built. Designed in an octagon, it was constructed to withstand the terrible storms and torrential rain and strong gales that are common in Matagorda Bay. The sheet steel piling used on the cofferdam was manufactured specially in steel plants in the state of Pennsylvania, over 2,500 kilometers away. And the steel sheets were made long enough so that they could be driven over 12 meters into the Matagorda Bay clay.
They had to be able to place the sheet piling in such a way that where they started here and they worked on around, that last one had to be absolutely precise so we could slide right down into the place it needed to go.
During construction of the cofferdam, crane operators used a machine called a mechanical vibrator to push these heavy sheets of steel into the bottom of the bay. Roughly 2/3 of the steel sheets were driven underground. Sand was deposited between the two sheet metal walls, 10 meters apart, to separate the center from the bay waters around it and to provide extra strength during storms. At 54 meters long and 40 meters wide, the Coffer Dam was said to be a gamble. After 1.1 million liters of water were pumped out, excavators and archaeologists could literally walk round and work on the floor of the bay, discovering artifacts. Engineers knew that the cofferdam wouldn't be watertight, but hoped to avoid a bad leak that could be catastrophic to the conservation efforts. Once brought to the surface, the delicate organic material that had been preserved in the oxygen-free environments of the dense clay for centuries, like the rigging and the sails, could just crumble away. These objects were handled with extreme care by expert conservationists.
Underwater archaeology, or nautical archaeology, maritime archaeology, is the only form of archaeology that has to have a conservator attached to the project.
And as we removed those artifacts and examined them, we realized what we had is what I call a kit for building a colony in the New World. These are the objects that an explorer coming to the New World in the late 17th century felt like he needed to build a successful colony.
The colony kit, loaded on La Salle's 4 ships, included 2,700 pounds of raw iron stock for making and repairing iron tools, 650 pounds of steel stock, 2 sets of church furniture, around 600 pounds of tools for carpenters, tradesmen and craftsmen, and countless other provisions that were essential for building a colony.
I mean, the colony kit, it certainly had the sort of day-to-day things you think of. There was a box full of cooking equipment. So you have brass colanders and brass pots and all the stuff you would have needed to cook. And they weren't part of the ship. I mean, these were things which they were bringing for the colony.
We found metal candlestick holders. We found dishes. We found jars that contained medicines. We found the remains of the animals that they ate. We found the actual bones, including the bones of the shiprat, the common shiprat.
And then you also have really what you need to build a colony. So you have casks full of nails. They brought blacksmithing equipment, so when they got there they could take the raw iron they had and turn it into tools. And then they had pre-made tools, such as axes, which they would have needed to cut down trees, work wood. So you have a lot of those type of objects. We have a lot of stuff that would have been used to build casks, because of course that'd be a really important way to package anything. So you have a whole cooper's bench, which was found in the hull. You have cooper's adzes and axes. All the specialized equipment for those sorts of trades that in a colony you would need to establish, because if you're going to be exporting materials, you've got to send them home in something.
It was clear from these artifacts that this ship's remit was to establish a greater French presence in the New World, which at the time was up for grabs between the British, Dutch and Spanish, all Old World enemies of France. From 1996 to 1997, archaeologists and excavators took the 1 hour and 15-minute boat ride out to the cofferdam twice a day from their headquarters in Palacios, Texas. Visitors came from all over the world to stand on the cofferdam walls and watch the archaeologists and volunteers find these amazing artifacts every day, with the waters of Matagorda Bay surrounding them on all sides.
When we were excavating the Belle shipwreck, and of course we had the Coffer Dam out here, we had a 17-mile commute, and usually we're pretty exhausted all these months of working, so we try to sleep if we could. So I got pretty good at sleeping in 4 or 5 foot seas.
The wind and waves were a constant reminder of the tragic fate that awaited La Salle's expedition.
I can remember as the sun set and our research vessel was on the horizon and things got pretty quiet out here, it really felt like once you were alone on this very spot, you could really imagine what it was like for these French sailors and colonists who I'm sure felt pretty alone because their home country was very far away and they were in a very rough space. And you think about their hopes and dreams. You think about those hopes and dreams being dashed to pieces when the ship ran aground to a shuddering halt right here on this spot where we are right now. Kind of sent chills down my spine.
In 1996, archaeologists began a massive excavation and salvage project to conserve La Belle, a 17th century barque longue owned by King Louis XIV. Archaeologists needed to confirm their finds, so they asked archivists to scour French and Spanish archives for additional written sources. One of the few surviving French colonists' diaries was key.
Archival records are obviously very important for this. I mean, we're fortunate that we have, from the French, a number of archival documents, and we were assisted by 2 different researchers, Bernard Ayer and John Debray, in the French archives looking up everything they could, and they found a lot of the information on the construction, letters of La Salle, hiring of different individuals who we know who they are now, we didn't know before, and then Jatel's diary, which had been published in the 1800s, or like 1700s, I mean, provides this amazing insight into somebody who was really there and tells this really interesting story.
Leading the expedition was the daring Frenchman La Salle, considered one of the most important explorers in American history. La Salle was from the city of Rouen, famous today for its beautiful cathedral. He left the Jesuit order to explore across the ocean from the French Atlantic coast.
In the United States, La Salle is very famous. He's one of the great explorers. He did great deeds of exploration in the Great Lakes. He built the first sailing ship on the Great Lakes. He discovered the mouth of the Mississippi River in 1682 and claimed all that land for France. That later became the Louisiana Purchase, measurably adding to the territory of the United States. The United States, in making that purchase, argued that Texas should be part of it because of La Salle being in here in Texas. So the Texas part of the overall La Salle explorations impacted the development of the United States as well.
For the French at this time, they wanted access, better access to the Americas, better ports, particularly in the south, which aren't choked with ice in the winter. But this would be invading on Spanish territory. So especially at the time that La Salle's expedition set sail, there was conflict in Europe between France and Spain. And this was a way, in many ways this was a provocation if they got caught, but it was also an attempt on the part of the French to claim more securely lands that were in North America that would provide them resources.
La Salle had made a case to King Louis XIV that France could gain immense wealth by establishing this colony at the mouth of the Mississippi River that would be a major hub for French trade in the New World. The La Belle set sail in 1684 as part of an expedition that had around 400 passengers and crew, comprising soldiers, clergy, and colonists.
La Salle came over with 4 ships. 2 ships, La Belle and Le Jali, were given to him by the king. He leased a 3rd ship, Le Mab, from a merchant to bring over, and then a 4th ship he leased, St. Francois. So the 4 ships came over. He lost his first ship as he was in the Caribbean, stopping in today's Haiti. He stopped there for a period of time, and just before he did that, the St. Francois, which was a slower catch, that's the type of ship it was captured by pirates or privateers, we don't know which, but people captured it for the cargo, and we don't know what happened to the small crew that was on that ship.
After the Saint Francois was taken, La Salle's company soon understood that this expedition would not be as easy as previously thought.
So La Salle continued on from the Caribbean, headed towards the Mississippi River mouth, missed it, landed in the Texas coast with 3 ships. A 2nd ship, Le Jali, had the orders to simply offload cargo, offload colonists, and sail back to France. And it did do that after it was here on the Gulf Coast for about 3 months, and it went back and made it successfully to France.
La Jolie, the small fleet's gunship, abandoned the expedition to return to France.
So ultimately, in late 1685, La Salle was down to a single ship, La Belle, as his lifeline to get help if things went really bad for his colony.
Losing Les Meubles prevented La Salle from perhaps completing a secret mission given to him by King Louis XIV, one that would have brought great wealth and revenue to France.
The majority of the money coming out of the Americas was in the trade in animal pelts. I think, and I'll quote him wrong here, but Louis XIV at one point made a comment that rather than animal pelts, he wanted silver from his colonies, like the Spanish were getting. So, aware that these materials were available in the Americas and having had very little success finding similar deposits up in the north, they took a strong interest in acquiring that land.
La Salle had an assortment of firearms and arms material that he brought with them, that in addition to forming a colony in the Gulf, which was supposed to be at the mouth of the Mississippi, La Salle was also supposed to use this area as pretty much a staging area for maybe a later military engagement against the Spanish to try to take the Spanish mines.
Geographical knowledge being as it was at the time, they didn't really understand the scale of what they were proposing. They didn't realize that it wasn't just an easy jaunt over to the silver mines from the Mississippi.
The colony kit, it turns out, also included over 400 firearms, as well as boxes full of swords and pole arms that were also recovered from La Belle's hull.
With the guns, there were petards, which is a very small explosive device that is often used to be affixed to doors, to blow in doors in fortifications. So we had petards, we had fire pots, we have pole arms, these are edged weapons, we have swords, and these light muskets and buccaneer guns.
Amy Borgens has photographed thousands of artifacts found in La Belle's hull, but firearms and weapons are her primary area of expertise.
Actually, I love the fire pots. For me, those were really exciting because it's a very dangerous weapon. The fire pots we have are explosive weapons. They contain a grenade. Some of them historically had more of a flammable liquid, so that when you threw them and they broke, they may cause a fire, but they wouldn't explode. They weren't explosive in the same way. But what I loved about it was the ceramic container itself. It just looks very benign and kind of harmless.
I'm not aware of any place in the world elsewhere that they have been found together like that you can peer back into the mind of what a French explorer needed to build a colony in the New World. But those artifacts in total are an amazing collection to allow us to understand how these colonies in North America and throughout the Americas were developed, how they were supplied. And La Belle is absolutely unique in telling us that story.
As archaeologists were uncovering the story of La Salle's presence in Matagorda Bay, word spread fast all over the world about the amazing artifacts being found in the cofferdam. La Belle's ownership came into dispute.
A short time later, a claim arrived at our offices from the French government, a claim for La Belle. They said that La Belle belonged to France, and they had submitted the claim to our U.S. State Department. U.S. State Department forwarded the claim to our governor's office, and the governor's office sent it to my office. And at first I was just, really upset about this, that we found this ship in Matagorda Bay, an interior bay of the United States. How could it possibly be claimed? And this wasn't fair, I thought.
La Belle is the property of the Republic of France. We came to realize that thanks to research that established that this was part of what the King of France considered to be his fleet.
We researched it further and learned that they were claiming the ship under international law of the sea, and that law basically says if you have a vessel that's on an official naval expedition authorized by the government, then no matter when the ship goes down, it's still owned by the flag nation, in this case France.
So when that came to light, there was a discussion between France and the United States. And of course the Texas Historical Commission, as the ones who discovered the ship and who recovered the ship from the bottom of the bay, from the bottom of Matagorda Bay, that required a lot of negotiation, discussion.
The United States, with the Texas Historical Commission, signed an international agreement with France that states, "The wreck of La Belle shall remain in the custody of the Commission for a period of 99 years from the date of entry into force of this agreement, which period shall be automatically renewed unless the parties agree otherwise." Meanwhile, in Texas, various experts at the Conservation Research Lab, as well as archaeologists, worked tirelessly to conserve not only the artifacts, but also the hull of La Belle in its entirety, after the ship's timbers were traced out on clear plastic sheets.
Waterlogged wood is not a material we generally think about for engineering. You wouldn't take this timber now and put it in your house as a foundation or studs in the wall. Over time, primarily through bacterial action, fungal action, a little bit of sort of a hydrolysis process, the cellular structure begins to break down.
In order to rebuild the hull of the ship, a carbon fiber and steel composite frame was built to support each timber. Custom steel bolts were used in the exact dimensions of the original holes that the 17th century shipwrights made while nailing the timbers together.
If any of this timber were to just be brought out of the ocean, laid out on the deck in a matter of hours, depending on how hot and humid it was, it would start to cup, it would start to move, it would dry out uncontrollably, and the forces and the tension on the degraded timber would crack it, split it. Eventually, when it was really dry, there'd be no binding or little binding material involved. It would probably just powder to pieces in a lot of spots.
Dr. Peter Fix has been working on the reconstruction of the La Belle shipwreck. In addition to being an expert in shipwreck timbers, he has worked for years in the conservation of the nearly 1.6 million artifacts found on La Belle.
We have processed all of the materials coming from La Belle. That would involve bringing in, accepting, documenting, photographing, drawing, sketching the artifact as it comes into the lab. It may involve, depending on what it is, it may involve x-rays, it may involve further analysis through spectrometry, or X-ray fluorescence or X-ray diffraction to determine what the best way of stabilizing that material will be.
Some of these items were so heavily corroded when they arrived at the A&M research lab, it was difficult for scientists to determine exactly what objects they were. Most artifacts brought out of the ocean environment cannot easily stay intact without proper preservation techniques. When a concretion arrives at the lab, conservationists can use it like a mold to make a nearly exact replica of the artifact. To do this, they drill a hole in it and pour in a plastic epoxy. Once the plastic hardens, skilled workers take electric chisels and slowly chip away at the concretion. What is left inside is often a near-perfect cast of the original object. The Conservation Research Lab here in Bryan, Texas, uses electrolysis to remove corrosion caused by oxidization on iron, bronze, and steel. Each tarnished artifact is submerged in a vat with a liquid containing a chloride solution. An electric pulse is sent through the vat, separating the corrosion from the artifact by changing the charge of the ions. This process attaches the corrosion to the charged ions, separating it from the artifact. The result makes the 300-year-old bronze cannon look newly forged. The lab is directed by one of the pioneers of these maritime archaeology conservation techniques.
We had to keep in mind that this ship does belong to France, and so we had to get an okay from France as to the major conservation decisions we made.
Dr. Donnie Hamilton has been doing this for 30 some odd years now and is acknowledged as one of the experts in the field. And the Conservation Research Lab has probably processed more bulk materials than any other lab in the country.
And it was decided a long time ago that we would do it by the 2-bath polyethylene glycol. Polyethylene glycol, it looks like a wax, but it's water soluble. And what it does, it just simply goes in as the water comes out, the polyethylene glycol goes in, and it just keeps the wood from shrinking and warping.
Treating La Belle in a polyethylene glycol bath allowed the CRL to work on the conservation of the hull completely intact. Ideally, they would be able to do this process twice to allow the chemical to fully penetrate the timbers. Although the Conservation Research Lab had given La Belle's hull its first bath, the planned second bath of the polyethylene glycol, or PEG, would cost over $1 million just to fill up the giant vat custom built for La Belle. To cut costs, the Conservation Research Lab scrapped the second bath and decided to use a giant freeze dryer instead.
It comes out with a much lighter color wood, a much lighter in weight wood, and each treatment, once you load the vat up, it only takes essentially 3 to 5 months to treat it. If we'd gone with the original treatment, it would have been a good 2 years before we'd been finished. And so we switched from it. And freeze drying is a very simple process.
The wood would have to be put through the machine in different batches, each batch taking several months to go through the freeze-drying process. So, after reconstructing the entire ship's hull to get it through the PEG bath, they would have to take it apart again, piece by piece. In the freeze dryer, each timber was frozen. Once the timbers were frozen, the freeze dryer turned into a vacuum, turning the ice crystals in the wood directly into a gas. This process, like with freeze-dried food, is called sublimation and works to preserve these organic materials.
Well, this is a big day in the conservation of the Belle material. It started arriving from the excavation primarily in the first part of 1997. So by May of 1997, all the artifacts had been delivered here for conservation. So now we've been conserving the artifacts for 17 years, and this is the last load of the wood of the hull, and so to finish the reassembly in the Bob Bullock Museum.
Dr. Donnie Hamilton and staff are pushing the last lot of timber out of the freeze dryer to be packed up and loaded onto the climate-controlled truck. After the freeze drying process, the timbers take on the hue or color that they would have had as brand new pieces of wood cut by the 17th century shipwrights. From here, the outer planking, which will be the most visible, was wrapped and transported from the conservation lab to the museum in Austin. When the timbers are finally put back together and bolted in place, the result of the conservation efforts is remarkable.
To me, it's terribly exciting in that I'm not aware of any place else in the world people are putting together an ancient shipwreck and inviting the public to come and watch us, ask us questions, and let us tell them what we're learning by putting that ship back together.
Here in Austin, Texas, conservationists and maritime archaeologists have reverse engineered a 17th century ship once thought lost forever. Today, it is being pushed into the museum's main atrium. Extensive work has been done to reconstruct La Belle's hull the way it was found nearly 20 years ago at the bottom of Matagorda Bay. Holding it together is a composite carbon fiber steel frame that is tilted 21 degrees, so when the masts are added and the ship is set, it will look like it did the day it sank. Journalists from around the United States are here to document the final step in La Belle's long, sad saga, as Dr. Jim Bruzeth and Dr. Peter Fix move the entire hull into its final resting place. This ship is direct evidence of a major historical moment.
Without this impetus, without this catalyst, I don't know what would have unfolded after many centuries. If we would be as Hispanicized. We are Texans, and as Hispanicized as we are, thanks to the French. It was a game changer, it really was.
La Belle is a shipwreck that changed Texas history and American history to a certain extent. If La Belle had not gone down, LaSalle's colony likely would have been successful, and our heritage, I think, in Texas today would be much more like New Orleans, where you have a French heritage as your past.
The story of La Belle attracted New York Times best-selling author Stephen Harrigan, who traveled down to Fort St. Louis with Dr. Jim Bruzeth to study the site of LaSalle's failed attempt at the first European settlement in Texas. 30 miles inland, up Garcitas Creek, near modern-day Port Lavaca, Texas, is where LaSalle decided to locate his new colony. He chose this humid, mosquito-infested swamp because it was on the highest point around for optimal defense. Because the area is underdeveloped, the threat of rattlesnakes and alligators is constant. In case of encounter with these deadly animals, a herpetologist and an armed guard accompany the crew. In LaSalle's colony, terrible mistakes put them in even more danger.
The problem for LaSalle is that when he was here, initially his interaction with the native Karankawa people was very positive. But at some point, some of his men stole some canoes from the Karankawa people. And that started the animosity and the warfare between the French and the Karankawa people. You got to look at it from the standpoint that the Karankawa, they were a mobile people, and so those canoes were the very existence of their mobility.
Here in this marshy land, the trees were thin and wispy, like overgrown weeds, mostly unsuitable for construction. With resources scarce, the Karankawas and French colonists alike struggled to find materials to build their communities.
House, and he used timbers from the wreck of the ship Le Mob, one of his ships that wrecked coming into Matagorda Bay, but they were able to scavenge a number of the timbers from it, and he brought them up here and used to build his French building that was the main place where when the Indians would attack, the settlers would all come and get into that building. He also cut down trees that were some distance away and brought the timbers back here to add on to that structure.
Thanks to Henri Joutel's surviving journal and letters, archaeologists and historians can paint a picture of what the conditions of Fort St. Louis would have been like in the autumn of 1685. One colonist died after being bitten by a rattlesnake. An alligator took another. Colonists learned to stay close to the buildings of their post. Unable to navigate up the shallow Garcitas Creek, La Belle was left in the deeper waters of the bay. In February 1686, a fierce storm blew in that forced the ship towards shallow waters and ran it aground. Most of La Belle's crew made it back to report the loss of the vessel, but one crew member perished. His skeleton was found in the hull centuries later.
I'm convinced that even though La Salle would have eventually, if La Belle had not gone down and been lost in a storm, would have found the mouth of the Mississippi River and built his colony there. But I feel confident he would have kept something over in this area here, particularly, as I mentioned earlier, looking at it as sort of a possible staging point for an invasion into northern Mexico. So I think it's entirely reasonable in my perspective that if the French settlement had lasted, that our heritage would be more like New Orleans, and we would not have the Hispanic heritage that we have today. Steve, what's your take on all that? You're writing a history of Texas.
I think you're exactly right. I think this is a pivot point of Texas history right here where we're standing. You know, I mean, it could have gone French, could have gone Spanish.
With their lifeline back to France severed, La Salle and some men, including Henri Joutel, began making their way towards the nearest French settlements, more than 2,000 kilometers to the north, in what is today Illinois.
Once La Belle went down in that storm with all of its supplies for the Mississippi River colony, La Salle knew that his colony was on the very edge of complete failure, and so that's when he decided he was going to have to take 17 men, leave this area, and walk to Canada to get help.
On the way to Canada, things for La Salle took a turn for the worse.
And as we know, on the way his men shot him around Navasota, Texas, and that ended the French effort to colonize. So really, it's La Belle and it's the sinking of that ship that changed our history.
Stephen Harrigan believes La Salle's domineering personality may have led to him being killed by his own men.
Definite explorer personality, too. I mean, he has that in common with almost any of these guys. Yeah, but that's the drive.
In his journal, Henri Joutel also wrote about the roses brought from France and planted on site. Though the fort was burned down and most of the colonists massacred by the Karankawas, those rose bushes still grow wild to this day.
Historical events oftentimes change on small issues, in small ways, and here it's the sinking of a ship that changed our history from what might have been a French history and opened the door for a Spanish history. And La Salle being in this part of the New World that Spain claimed back in the 17th century, and La Belle being here, is what awakened Spain to realize that if they were going to hold on to what is today's Texas, and they had nobody up here occupying it, if they're going to hold on to this land, they needed to send people up here because the French would come back again and try and conquer and occupy this part of the New World.
That is exactly what the French did in 1718, when the French Mississippi Company founded New Orleans. The French influence in Louisiana is still very visible today in the architecture of churches and buildings throughout the southeast. La Salle is a hero here, revered as the first explorer to sail down the Mississippi all the way to the Gulf of Mexico. Many French and Creole French speakers also moved to Louisiana, especially after the Haitian Revolution, leaving a mix of cultures brought from the descendants of Native Americans and African slaves brought over by the French. At night, New Orleans comes alive with the sounds and music preserved from this eclectic mix of cultures. A very different place from Texas.
There's this mystique about Texas, and there's, you know, for good or bad, they understand that we're about cowboys and cattle and all of that. Well, those are grounded in our Spanish heritage. Well, our Spanish heritage is as rich as it is in Texas because the Spanish found out that La Salle, this French explorer, had intruded on the territory of New Spain.
The legacy of La Belle is of lasting importance, both historically and technologically. The sinking of this tiny vessel may have altered the course of history in the Old and New World. The Coffer Dam was both a staggering feat of engineering and a gamble that paid off for archaeologists on this scientific salvage. The conservation strategies used to excavate and preserve the ship and all its artifacts will be used as examples of maritime archaeological techniques for decades to come.
This is really a textbook example. I mean, any student of marine archaeology, of shipwreck archaeology, is going to read about the Belle, is going to learn about the Belle.
La Belle may have been a small ship, but she left a very large wake, one that is still rippling across the world today.